So this is lesson 3 for our energy lessons, and this lesson will be on light and sound energy. The learning intention for this lesson will be to able to understand how sound and light energy travels from one place to another. And the success criteria are these. So these are the things that you should be able to do by the end of the lesson. And they are identify that sound energy travels through vibrations, to be able to identify that light travels in straight lines, can explain why sound cannot travel through a vacuum, and can recall that light can travel through a vacuum. So these things are the things you should be able to do by the end of this lesson. So let's make a start. Okay, so let's start with sound energy first and ask ourselves, how does sound energy travel? So if you are talking to another person, okay, how does the sound of your voice get to the ears of the other person? And how does their voice travel to you? What it essentially is that sound energy travels through vibrations. Vibrations is a word that basically means that something is traveling back and forth really, really quickly. So back and forth really, really quickly. So for example, vibration, I guess another word for it will be shaking back and forth. Okay? And you can feel that sound comes from vibrations by speaking and holding your hand just at your throat. Okay, so when you speak, your vocal cords in your throat vibrate to make sound. So if you just place like a couple of fingers on your throat while you're speaking, you can actually feel that your vocal cords in your throat are vibrating. They're actually shaking really fast back and forth to be able to produce sound. Another example is when you play a drum. Okay, so I'm pretty sure all of us here have hit a drum sometime in our lives. When you actually hit the surface of the drum, the skin that makes up the surface of the drum actually vibrates in order to make sound. Okay, so whenever you hear sound, it is vibrating. I guess another example is if you have ever seen the movie Jurassic Park 1, what happened there was, how towards sort of like the end of the movie, and there was those two children who were eating like jelly and stuff like that on a really big dining table, and the dinosaurs were hunting them. And then in the glass of water, what they saw was the water vibrating, the water was shaking. And that was because the sound that the dinosaur foot prints were making, so the dinosaurs walking towards them were making, the sound was traveling through vibrations, which was making the water shake as well. So the important thing to remember in for sound energy is that sound energy travels through vibrations. Okay, so vibrations is a really, really important word for sound. Okay, so we know that sound is made by vibration, so that, if I was talking, okay, so if I was talking, the vocal cords in my throat will be vibrating to make the sound. Okay, but let's look at what actually happens to that sound for it to get to the person's ear here. Okay, so let's say this sound, okay, is made by some sort of vibration. Okay, what happens is that vibration, that shaking back and forth, that pushing back and forth, what actually happens is that it pushes the air around it as well. Okay, so let's say this is the sound here, and then what happens is this sound pushes the air particles to vibrate. So the air particles sort of vibrate back and forth, 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 until it reaches that person's ear. Another way to look at this is it's like if you were, how sometimes when you're lining up for the canteen or lining up for something, you've got a whole bunch of people standing in line. Okay, so these are like the particles of air. Okay, so you've got a whole bunch of people standing in line. And what happens is that, just say if this person all of a sudden started pushing, okay, they started pushing back and forth, so they pushed this way and then they went backwards, this person can then go and push this person, and then they push this person, and they push this person, push this person, push this person. Okay, so that whole kind of pushing energy is traveling from one place, this place, to another place. And that's basically how sound energy travels. The sound energy starts from an initial vibration. Okay, so something is shaking. Okay, and that makes sound. And that vibration causes the air particles here. It pushes this air particle, and then this air particle, and this air particle pushes this air particle. This air particle pushes this air particle, and so forth, until all the pushing eventually results from the sound traveling from one place to another. Okay, so remember, vibrations is the key point in how sound energy is made and how it travels as well. Okay, now this phrase here, in space, no one can hear you scream. I'm pretty sure you've heard of it before, and it actually has some scientific accuracy to it. Okay, in space, that means in the universe, what's between our Earth and our Sun, in our solar system, in space, there is nothing. So there is no particles in space. There's no air. There's no anything. Okay, so space has no particles. Okay, that means it is a vacuum. A vacuum is any area that has no particles. It has absolutely nothing. Now, if you think back to the previous two slides, we said that vibrations are really important, okay? Sound energy needs to come from vibrations, okay? Something needs to be shaken in the first place, and also it needs something, okay, for it to travel from one place to another. It needs like air particles, okay, for it to push forth, to go from one place to another. If the sound is in water, it will push water particles. If the sound is going through a piece of wood, it will be pushing the wood particles. So if there is nothing to vibrate, it will mean that sound cannot travel. So if you think about it, in space, no one can hear you scream. That will mean that sound cannot travel in a vacuum, because there's nothing for the sound to push to be made in the first place, and there'll be nothing for the sound. There'll be nothing to carry the sound. There's no particles to carry the sound from one place to another. Okay? Now, if we have a look, let's say if we've got like a person speaking. Okay, there's my person speaking, and there's another person listening on the other side. The space that the sound needs to travel is called the medium. Okay, so the medium is what sound energy is traveling through. So if in this case it will be, just say if it was air, okay, air will be the medium. If these two people were underwater, water will be the medium. If they have to, there was a big war between them, then it will be the war that will be the medium. Whatever the sound is traveling through, it is called the medium. Okay, so usually it's air. It could be anything though. It could be water, it could be concrete, it could be wood, it could be plastic, it could be anything. But sound needs a medium to travel through. Sound needs a medium to travel through. Now that we've looked at sound, let's look at light energy. Okay, so you would have noticed that, as a child, when you draw the sun, you would always draw the sun, with a circle, and then you would draw like straight lines coming out of the sun. There's a reason why we do that, okay? So for example, this light bulb, you often see pictures, they will have straight lines coming out of the light bulb, the light source, to indicate that there's light coming out of it. There's a reason why we draw straight lines and we don't draw, like curly lines or bendy lines. And that's because light travels in straight lines, okay? So they travel in straight lines, and we call these lines, and when we draw these lines here, we call them light rays. Okay, so one ray of light is like one line of light that is coming through. Okay, so light travels in straight lines. So how exactly do we see them if light travels in straight lines? Okay, so what happens is, just say, for example, this person here, this boy here, he is looking at a window. Okay, so what happens is that light from that window, it has light from a torch that has went into a straight line into the window. Okay, and at the window it can bounce back and go into the eye of this boy. And once it gets into the eye, the light ray will then be interpreted by the brain, and then the brain will, like say that, we can see the light of a torch coming from a window. Okay, so the important thing to remember is that light travels in straight lines. When light rays hit an object, they bounce back, and we see when light rays are bouncing from an object goes into our eyes. So if we look at another example, so another example is, to say this is us here, okay, if this is you, okay, two huge eyes, these are your eyes, okay, and just say you're looking at a tree, okay. Remember, these drawings are not to scale, so there's no way, this either is a very small tree or you are a very, very tall person. Okay, so let's give this tree some color. Okay, so you're looking at a tree. Now, because it is a bright sunny day, so there's light everywhere. Okay, so what happens is there will be light that has, shined onto the tree, and then that light travels in straight lines. That light goes to the tree and it will bounce back, and the one that gets into your eye will be the one that your brain is using to interpret that this object is a tree. Okay? So light just travels in straight lines. It is not like sound. It doesn't need to push particles through the air, or particles through the ocean, or particles through like plastic or whatever it is. It doesn't need to push anything. Okay, it doesn't need something to be vibrating to start. It doesn't need anything to be vibrating to continue. So that means that light can travel through a vacuum. Now remember, a vacuum is anywhere that doesn't have anything, so it has nothing. A vacuum means that there is nothing. There's no particles, no air particles, no water particles, no any type of particle. Okay? Now, space, remember, is an example of a vacuum, because in space there is nothing. So if you think about it, we on Earth, the sun is here. This is the sun. Okay, and then you've got Mercury, Venus, Earth, and we are here. And the sunlight needs to travel from the sun to Earth. And all this area is vacuum, is space. Okay? So that means that light can travel through a vacuum, because we can see the sun from Earth. The reason why light can travel through a vacuum is, let's notice a mistake there. That should be through, not though. This should be through. Okay? And the reason why light can travel through a vacuum is because light doesn't need vibrations to travel through. It can travel through anything. It travels in a straight line. It doesn't start with a vibration. It doesn't need vibrations or pushing of particles to get from one place to another. And that's why light can travel through a vacuum. Okay, so let's recap on what we've done so far. this lesson, we have talked about two things. We have talked about sound energy, and we have talked about light energy. Okay? Both of these types of energy can travel from one place to another. So for sound energy, it needs to be vibrations. That is the main thing. It needs vibrations. For light energy, no vibrations are needed. Okay? Light energy also travels in straight lines. Okay? Now, sound energy, what happens is that it needs a medium. Remember, a medium, it is anything that the sound is traveling through. Light, okay? Light is a different story. Whereas sound needs a medium. It means that it cannot travel through a vacuum. Cannot travel through. Oh, spelled vacuum wrong. Vacuum. Whereas light, because it doesn't need to have vibrations, it can travel through a vacuum. Okay? So those are the important things to remember. If you can, remember the sound travels through by vibrations, that it needs a medium to travel through because it needs to push the particles in the medium to get from one place to another, and that means it cannot travel through a vacuum. And you know that light energy does not involve any sort of vibrations. It travels in straight lines, and because it doesn't need any vibrations, it can travel through a vacuum. You would have satisfied all of the success criteria we talked about earlier in the lesson. Okay? And that brings us to the end of the third energy lesson on light and sound.